For the second part of section 2.8, we're going to talk about absolute value. And absolute value is written with these lines like this. And it just means that it's the distance between x and 0 on the number line. So how far away from 0 is that particular number? Next here, we have three different scenarios. These are very, very important. If it's an equal sign, you can divide it up into two different problems where the a value is negative or positive. So this right here just stays the same. And then this one, the a becomes opposite. And so it's either one or the other answer. If you have an is less than inequality, so is less than or is less than or equal to, either one, it's going to have an and in the middle. Remember, those are conjunctions when they have the and there. So it's both answers. And you simply, to solve it, you break it up into two problems. You keep it the same without the absolute value. And then again, where you flip the sign and make the a value negative. And then moving on to the third one, that's where they're greater than, and greater than or equal to also fits in this category. So again, two parts. Keep it the same without the absolute value, or you flip the sign and make the a opposite again. And this is an or in the middle, so this is a disjunction. And remember, with disjunctions, one part has to be true. With the conjunctions, both parts have to be true. So moving on to solve some of these, the first one is the absolute value of x minus 7 equals 5. So we're going to break this up into two problems. X minus 7 equals 5, one without the absolute value, and then one without the absolute value, and the a is opposite, so that 5 is now negative. So I'm going to add 7 to both sides. You're going to have x equals 12. And then for this one, we're going to add 7 as well. And negative 5 plus 7 would leave us with 2. And this is an or, so x is either 12 or it's 2. And then this one, if it has an equal sign and it has something that's not in the absolute value signs, then we have to move that first before we break it into our two parts. So I'm going to subtract 5 first. So I have the absolute value of 3x, and then 14 minus 5 would be 9. Now I can break it into two parts. So 3x equals 9, and 3x equals negative 9. Divide by 3. So x equals 3. Divide by 3 here, and x equals negative 3. Remember, one or the other. So it's either 3 or negative 3 that make that equation true. Now we're going to move on to where we have inequalities. This one has an is greater than sign. So if we go back up here to our chart, the greater than signs are the disjunctions, and that's where it has the or in the middle. So we're going to have to remember that when we solve. So we are going to have one without the inequalities, and then one without the inequalities where we flip the sign and the a becomes negative, so that 5 is now negative. And then solve just normal, minus 1 from both sides, so 2x equals 4. And then divide by 2, so x equals 2. And then move over here, minus 1, so 2x equals negative 6. And then divide by 2, x, bring down that sign. Negative 6 divided by 2 is negative 3. And I realized I brought down an equal, not the regular sign there, so fix that. And remember, this was an or, Then we have to put these on a number line. So x is greater than 2, so circle at 2. It's not underlined, so it's going to be an open circle. And greater than goes to the right. Or x is less than -3. So less than goes to the left, and we shade in there, and the circle is open. And then we have to write our interval notation here. So the first one is greater than 2, so it starts at 2 and goes to positive infinity. We can't include positive infinity, and the circle at 2 is open. So both of those are parentheses. And then or, remember, was the u from yesterday. And then we have the other set here, x is less than -3, so we're starting at negative infinity. We don't include it, so it's a parenthesis, and we're going to -3. And we're not including that either because it's a circle. It's open circle. And then for set builder notation, remember, we just bring down the two inequalities that we got, put the u in between them, and we're good with that. All right, for this next one, we have that plus 16 that's on the same side with the absolute value, but is not inside of it, so we have to get rid of that one first. So we're going to minus 16 before we do anything else. So we have the absolute value of 4x is greater than 8 minus 16, which would be -8. And then we can break that up. So we have 4x is greater than -8, and 4x, flip the sign and make that a, that -8, opposite. So that's +8. And then we divide by 4 on both sides. So x is greater than -2. And for this one, divide by 4. So we have x is less than 2. And remember, these are ors with the greater than symbol. So then we have to draw it. So x is greater than -2, so circle at -2, greater than goes to the right. And then x is less than 2, circle at 2, and that would go to the left. And because this is an or, we learned yesterday that only one of these has to be true. So this could be all real numbers because the -2, all the numbers greater than -2, and then all of the numbers smaller than 2, that takes care of every single number on this number line forever in both directions. So if we were to write our interval notation, we would say it's from -infinity to +infinity. Next on our list here is this one. We're going to solve and graph our solutions. Again, this one has a less than symbol. So if we go back up to that chart, less than is a conjunction, and that has the and that means that both of our inequalities that we get at the very end have to work. Both of them have to be true, where if it's an or, a disjunction, only one of them have to be true. Oops. So we are going to do the same thing for solving these. We have to get rid of that divide by 2 first, so we're going to times by 2. So we have the absolute value of 3x minus 9 is less than or equal to 24. And then we can split that up into our two problems. So we have 3x minus 9 is less than or equal to 24. And 3x minus 9 is greater than or equal to -24. Remember, flip the sign and make the a opposite. So then we add 9. 24 plus 9 is 33. And then divide by 3. So x is less than or equal to 11. And then add 9 over here. It's greater than negative 24 plus 9 would be negative 15. Divide by 3. X is greater than or equal to a negative 5. And remember, these are ands. You have to put these on a number line. So x is less than or equal to 11, so 11's right here. Less than goes this way, all the way forever. And then x is greater than negative 5, greater than or equal to, so negative 5 is right here, so it's a filled in circle, and greater than goes that way. And remember, with the ands, it's between the two dots where they overlap is our answer. So the red spot here would be where we're talking about. And if I wrote this into set builder notation, we would have our inequalities. Our smallest number is negative 5. And we go all the way up to 11, and both of them are included. And then if we did interval notation, we would start at negative 5, and that's included because it's circles filled in. And we go all the way up to 11, and we include that as well. And then we have one more problem here to look at. We have to divide both sides by negative 4. And so we have the absolute value of x plus 3. Remember, when we divide by a negative, we have to flip that sign. So we get negative 2. And then, we break this up. Keep the sign the same and the a value the same. And then the other one, we want to flip that sign and make that a opposite. So I'm going to subtract 3 from both sides. We get negative 5. And over here, minus 3 from both sides. 2 minus 3 would be negative 1. If I graph this, this is what it would look like. Our x is less than or equal to negative 5, so anything to the left of negative 5. And then x is greater than or equal to negative 1, so anything to the right of negative 1. And notice this was an and because of the inequality symbol that it gave us. And an and has to have an overlap. So our answers are where they overlap. And this particular graph doesn't overlap. So there's no numbers that work for both inequalities. So this is no solution. So there's nothing in the set. So if there's nothing in our set, then we would draw a circle with a line through it to show that our set is empty and that there's no solutions to this.